Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over primitive data types as well as variables in JavaScript. We're going to use a series of different tools to kind of describe this. I'm going to both code as well as kind of show some diagrams that I have prepared just so it's a bit easier to visualize what's actually happening behind the scenes. Let's get right into it. All right, so I have Visual Studio Code open. I encourage you to open up a folder inside of Visual Studio so that we can actually add a couple of files if needed for this video as well as others in the future. I'm going to actually switch over to another program where I have some drawings ready just to start explaining these concepts. So we're going to flip back and forth between coding and drawing for this concept. All right. So in most programming language, there is this concept called primitive data types. So what does that mean? At its core, computers can really understand a few very basic things. So in JavaScript, to keep this simple to start, there are these 5 different primitive data types. So these 5 basic structures that the computer or JavaScript understands. There's something called a string, a number, a Boolean, and then these 2 other values, null and undefined. There are technically 2 other primitive data types in JavaScript that are a bit more advanced and were added later in the language called big int and symbol. I'm just going to keep this here for sake of completion, but we're not actually going to go over this for now since they're a bit more advanced in their use cases. So what are these ones over here, these primitive data types? A string is a series of characters. So you can think of something like a name, right? So my name's Nader, I would say Nader, that would be a string. Monkey would be a string. Your name would be a string. A city that you live in, that would be a string. We'll go over some examples in code in a second. A number is just what it sounds like. That's any number that you can think of, 0, 1, 2, 3, very large numbers, as well as numbers that have decimal places, so something like 3.14, or pi would be a number in JavaScript. Other languages actually make a distinction between numbers that have decimal places and numbers that don't. This distinction does not exist in JavaScript. Everything that's a number is simply a number nicely in JavaScript. Boolean is one that's a bit funky sounding. It comes from a nice mathematician called George Boole. But this is simply 2 values. It can either be true or it can be false. We're going to use this quite extensively when we look at conditional statements and how this can be used to create very complicated programs that do various complex behaviors. However, at its core, it's true or it's false, and we'll see those 2 values as well. Now, JavaScript and most languages have a value to describe the absence of a value. So in JavaScript, this is called null, this one right here, N-U-L-L. We'll actually see how that works. As a quirk of history and how JavaScript was designed, there's also technically another value for this absence of a value or absence of behavior, and that's called undefined. This is unique to JavaScript and doesn't exist in most languages. It's kind of a quirk of the language. Lots of debates online about this, but null and undefined for our purposes are kind of the absence of something or not having a value, and we can see how that'll be useful shortly. All right, so I have several other examples to show you, but let's get into the code so we can actually see what this looks like in practice. So back in Visual Studio, go ahead and create a new file. I'm going to just call this primitives.js. Make sure you have the JavaScript extension. All right, great. So there are 2 ways to actually create variables in JavaScript. There's actually a third way that's a bit older and less used. I'll quickly mention it at the end of the video. However, I'm going to go over the modern ways to actually code with JavaScript because that's what we're going to see when we're actually working in code bases these days as developers. To create a variable, we always want to use kind of one of 2 words. And I'll start with the first one so I can show you something that is not possible with the second one shortly. We're going to use a let keyword. And this is saying that we're defining a variable, and right after this let keyword, we're going to use the name of the variable that we want to refer to something. So let's say that we want to make a city, something that refers to a city, like say Toronto, okay? I can create a variable called city, and then I can assign it a value called Toronto like this as a string, okay? In JavaScript, strings are surrounded by double quotes or single quotes. You just need to make sure that they match. what you use is mainly a personal preference thing. There's a lot of people have wars online about this kind of thing. It doesn't really matter. Just pick one that you're comfortable with and keep using it and keep it consistent throughout your code base. That's the only thing that really matters. When you're working on larger teams, this process usually gets automated and a program goes in and changes them all to be consistent across the team anyways. So this line of code right here is saying let, which means create a variable. We're calling the variable city, and we're assigning it a string, which is going to be Toronto. All right, and it's a string of characters. That's kind of where the name string comes from. It's Toronto. Okay. We could alternatively have done this in a different way. So let's say we wanted country. All right, so I could do like let country. In JavaScript and most languages, I can actually declare the variable separately of actually assigning or initializing the variable. In this case, I'm just saying, hey, JavaScript, create this like country variable or label, and I'm going to give you a value for that later. So I could actually do this. I could then say country is equal to Canada, for example. All right. You can see now with these two side by side that in this example, we actually did both the assignment and the declaration of the variable both in one line, right? So the declaration is right over here on the left, and then the assignment is happening here with the equal sign and then the value on the right. In this example down here, though, we're actually kind of creating the variable over here, and then we're actually assigning it a value over here on the next line. And this could be many lines down, this could be never technically, but these are totally separated from each other. All right, it's an important distinction to make, and this will come up quite often as you're doing development. So just keep in mind, there are these two ways of doing things, and the most important words to kind of keep in mind when you're thinking about variables is the actual declaration or creation of the variable itself or the label itself, as well as a second step, which is the actual assignment or initialization of the variable. Okay, you can do it in one line, or you can do it in a series of lines. Now, since these are variables, they can actually change. So in the example of country here, I can actually change the country again, because country is just something that points to this string. So I can then say country is equal to, for example, India. All right. So in this case, this is totally valid. This is totally valid JavaScript. It would actually run if we were to actually use this anywhere in our code. We're basically saying, hey, create this thing called country. First, change it to Canada. Later, I change my mind. I want to change it to India, and I could change it to any other country later on if I want. All right. The reason that this is possible is because of this special keyword right here, let, which, as I mentioned earlier, is one of two very important keywords for variable declarations in JavaScript. The let keyword allows us to change what the variable is pointing to in the future. So right here, it's pointing to Canada, but over here, it's pointing to India. All right, so why is this kind of let keyword important, and how does it differ from other possible keywords, and how does this actually work inside the computer? I made a drawing for this. So in this example, as you can see, we have the code at the top and then kind of a diagram that explains it on the bottom. I'm saying I want to create a variable using let that's going to be able to be changed, and it's called name. And I want to assign that immediately to a string that says monkey. Then right after that, I want to reassign the name label to the string wolf. All right. So what this looks like inside the computer is there's really actually basically a table, and that table can store different bits of data. In this case, it's storing strings. So we're storing the string monkey, and then we're storing the string wolf. All right. We're creating a variable that can point to these different strings. In this case, that variable is called name. So name was first pointing to monkey, and then on the second line of code, we switched where it's pointing to wolf. The other string monkey technically still exists. It might get deleted to save some space. JavaScript kind of deals with all that behind the scenes. But the main point to make here and to kind of recognize is that there is this table. It's quite literally a table inside the computer that stores all the data for the variables. And you can visualize it just like this, where you have the table and then you have the values in the table as well as these variable names, and they literally point to where that value is inside of the computer. All right. So I said that there were kind of two ways that we could set up these variables. So before we get to the other variable or primitive type, I want to show you the second way, which is called const. So we saw let so far, all right? But const is the other major way to declare these variables. So let's say that I wanted to create, let's say like my name. And I want my name to be monkey, just like that. Put a semicolon over here as well. This looks very similar to kind of line 1, right? Except the only real difference is that I'm using const instead of let, and I'm using a different variable name, in this case literally name, as well as a different string that I'm assigning to it. As you can probably guess, const variables cannot change once they've been declared and initialized. All right, that's the main difference. So I cannot do this. I cannot say name is Nader next. This is not going to work. Okay, I will get an error, and JavaScript is going to yell at me, and my code would actually break if I tried to do this. And the reason is that const comes with this added safety or benefit, depending on how you're coding, that kind of reinforces this extra rule behind the scenes, so we can't accidentally change name to point at something else. So this is holding name constant to always be pointing to this string monkey. It can never point to anything else. This might seem very restrictive and very limiting. However, there are many cases where this is extremely useful. In fact, as we're beginning development, I would encourage you to always start your variables as const declarations instead of let declarations. We can get into the reasoning for that in a future video. However, I'll kind of be going with that pattern, and then we can later change our const variables to let very easily by just changing this keyword if we do actually need to change it. This is a nice safe thing to do as you're getting started, so you don't accidentally end up changing variables kind of out from under you. All right. So that's how strings work. And to kind of give you an example of the const, right here is a const variable. So it looks the exact same way. We're creating a const variable called name, and then we're pointing it at the string monkey, just like this. All right. So what are the other data types? This should go a little bit faster since all these concepts actually stay the same for the other data types. So these ones are all strings over here. I'll actually put in a comment in JavaScript, which is ignored by the interpreter, so that we can safely put things inside of here that are not actually keywords in JavaScript. And we can do comments using the double slash. So // and I can put this is all strings. Over here, I'll put a // and then the next ones we want to look at are numbers. So numbers are pretty self-explanatory. I can use const or let as well with them. So I'll do one for const. I'll say const age equals 20. All right. I can say let price equal to 1.23. Both of these are numbers. In this case, I am saying I am creating a constant variable called age and pointing it at the number 20. I am creating a variable using the let keyword called price, and I'm pointing it at the decimal number 1.23. JavaScript does not kind of distinguish between decimal numbers and kind of integer or whole numbers. All right, so keep in mind again, I cannot do this. I cannot then reassign this. This is not going to work. However, I can reassign price to something else if I want to. Okay. I'll get rid of that just so that we have this nice and clear. Finally, we have the Booleans, which can be one of two value. I'll create a const Boolean. I'll say happy, and this is true. So true is the Boolean value in this case. I'm creating a variable called happy, which cannot be changed to something else, and it's pointing to the value true. And then I'll say, let's do let sad equal false. All right. So this is a second variable. This one can be changed to something else in the future if we don't want it to be false. However, these are the only two possible values for a Boolean type in JavaScript. Okay. So we've kind of seen these three so far, right? These are the most kind of common ones that you'll come across. Let's just quickly look at null and undefined as well to see how those work. Those are null and undefined. these are actually both quite common. I was going to say null is probably more common, but they're actually both very common. We'll actually see them pop up all over the place in JavaScript together. Let's just do this. Let's say const empty equals null. And then we'll say const empty2, can't type today, equals undefined. All right. So the most important thing to keep in mind here is the value on the right-hand side of this variable initialization. We have null, which is its own value type, and then we have undefined, which is its own value type. And in this case, I'm actually pointing empty at null and pointing empty2 at undefined. And these can't be reassigned later on because they're const variables. Okay, so there you have it. These are all of the primitive data types in JavaScript except for big int and symbol, which are a bit more advanced and you rarely used in practice day to day for your average developer. It takes quite a bit of practice to kind of understand how the quirks of some of these might work. So what I'll do is actually create a separate series of videos that kind of go into some problem sets. But before we do that, I'd just like to kind of hammer home the concepts using a few more drawings. Let's look at this one. This is creating a name variable that can be changed because it's let, and it's pointing at the string monkey. Then we're reassigning it to woof, which is also a string, and then we're reassigning it again to a number this time, 42. All right. So in the kind of computer's memory, in this table, you would have these three values. First it would be monkey, and then it'd be woof, and then it'd be 42. And you can picture kind of name jumping between these three different values as these lines of code are being run and being changed. All right. In JavaScript, there's no concept of limiting a variable to a specific data type either. In a lot of other languages, once you create a variable that points to a string or points to a number, it can never ever point to another data type. However, in JavaScript, since it's a dynamic language, it can actually point to any data type. All right, so there's a lot of pros and cons to this. Also a lot of fighting online about this feature. However, I would say, especially when you're starting out, this is a very useful feature. And even as you get more professional in your development, I would still argue that this is a very helpful feature, especially when you kind of know the ins and outs of it. Here's an example using two variables. The first one is a const label called name that's pointing at the string monkey. The second one is a variable using let called age, just pointing at the number 15. This is what it would look like in memory. All right, so in this example, we have a constant variable called name. It's pointing to the string monkey. Then we're creating a variable called age, which can be changed, pointing at the number 15, but then immediately after that, we're changing it to be 20. So inside of that table in the computer, you can see that name is pointing to monkey, which makes sense. We're creating 15 and pointing age to it, but then right after that, we're pointing age to 20. So 15 might exist for a little while, it might get wiped out for efficiency purposes, but this is what the state kind of that table in the computer would look like once this code actually runs. In this example, I just want to demonstrate that these are totally unique, what are called immutable values. So we have a const variable called name pointing it at the string monkey, and then we're creating another variable called my name, which can be changed, but it's also pointing at monkey. All right. So why is this kind of weird, right? If you look at the actual table, you'll see that name is pointing to this kind of block right here, which has the string monkey, but then my name is pointing to another block, which also has a string monkey. Right? So kind of intuitively, this feels kind of weird, right? Because you would think that, maybe why aren't they pointing kind of the same thing here like that, right? So why aren't they pointing both to this first block? The point of primitive data types in every language is that they're always going to be a new section in this table, a new block. All right. So what we can do is we can actually change my name to something else if we want to. And it would create something over here maybe, but we wouldn't be impacting name or we wouldn't be impacting this value over here. This is going to take some practice to kind of get used to, but I just wanted to demonstrate this since this does trip people up when they first see it, and visualizing it is really the best way to kind of figure out what's happening behind the scenes. All right, so to really hammer that last point home, this is what it would look like if we did change that second variable myName. So the first variable is still a constant, it's called name, and it's pointing at the string monkey. Then we're creating a variable called myName, which is declared with let so that we can change it, and it's also pointing at monkey, which would actually be this one here. So on line 2, it would be the same setup as the previous slide. It would be pointing to monkey just like this, but it would be a separate monkey from the first one. However, we're then changing what myName is pointing at, and we're pointing it to another string, in this case myName, which is natter. All right. You can see that inside the computer, there's actually 3 strings being created, right? Because they're all separate and independent of each other. Eventually, this second one here will probably get erased again to save space. However, visually and just conceptually, this is what's going on behind the scenes inside the computer. All right. To make things a bit more complicated, let's go through a couple more examples just to really hammer this home. Here we're creating 3 variables, all constant. The first one, var1, is a string hello. Second one, var2, is pointing to a number 42. And var3, also constant, is pointing to another string hello. So you can imagine, in this case, I just showed that there might be other variables happening in the program or some changes happening where these other values are being shown in this table. However, we don't have any variables that we're seeing right here in the code pointing to them. They might be pointed to by something elsewhere. So var1 is pointing to this hello, var2 is pointing to 42, and var3 is pointing to hello. And like one of the previous examples, these are both the same hello string, but they're actually independent and in different spots. So it's actually a duplicate hello string. They are actually not really the exact same hello string, even though they contain the same characters as a string. All right, so these are 3 separate variables pointing to 3 separate locations in this table, each with their own independent values. All right, so to make this even more fun, I just added kind of a little bit of a trick here. The only difference between this and the previous picture is that I've added a var4. So we can actually assign variables to each other. And in this case, with primitive data types, since they're all independent values, every time we assign a variable to some value, it's always going to be duplicated. It's not going to point to the same thing ever with primitive data types, right? So that's strings, numbers, Booleans, null, and undefined. So you can see that even though var4, which I've added, points to var3, which is pointing to hello, it's not going to do this. It's not going to point here just like that. That would kind of violate this idea of a primitive data type, because changing one would then change the other, which is not what we would want. Even if these were lets, that would not be good. So actually what's happening is this. It's creating a duplicate of var3 and storing it somewhere else in the table and then pointing var4 at that. So these 2 variables are totally independent of each other. This is different behavior from mutable data types, which we're going to get to in future videos. However, for the primitive data types, this is always true and consistent behavior across pretty much every single language, including JavaScript. All right, so for this final example, which is very similar to the previous one, except with some extra tricks thrown in just to really hammer all this home, we have 4 variables again. So we have var1, 2, 3, and 4. var1, 2, and 3 are all constant, right? So we have var1 pointing to hello, var2 pointing to 42, and var3 pointing to hello. But this hello is a different hello than var1, so it's actually a different entry in the table. The tricky thing here is var4 is declared with let, which means that it can actually change what it's pointing to. To start, it's actually pointing to var3, which, as we mentioned in the previous picture, looks like this, even though it's declared with let. So that actually creates this hello entry right here. Okay, so it would actually, if we didn't actually run this last line of code, which is changing it to meow, the diagram would actually look like this. var4 would be pointing to a separate hello. However, in the last line, we're changing var4 to now be another string, which is meow. And that's going to create another string in this table and then point var4 to that. However, this hello might still exist for a little while until it gets cleaned up by JavaScript behind the scenes. Okay. So that's pretty much it. That's how these variables work in JavaScript, for the primitive types at least. In a future video, what we're going to do is look at some of the more advanced data types, such as objects and functions. However, we're going to be able to stick with primitive data types and get quite far. What I'm going to do in the next video is I'm actually going to create some problem sets that if you're interested in actually walking through some of these problems and some of the tricks that might pop up, we can work through together. I hope you enjoyed this video. I hope you found it valuable. Please like the video and subscribe to the channel, as well. I'd love to hear comments and feedback from you inside the comments section. Until next time, I'll see you in the next video.